Hello again. Welcome back. We have been doing quite a bit of work with learning how to use the periodic table to tell us how atoms are going to behave. And when we talk about behaving, we talk about those atoms forming bonds. And so we're going to talk a little bit more about that today. All right. So what determines an element's chemistry? Now, we know that absolutely everything around us is made up of a combination of the atoms, of the elements on the periodic table. And of course, those atoms combine in different ways, in specific ways, depending on their valence electrons. And we have been talking a lot about valence electrons, specifically those electrons in their outermost energy level. And we know that the first energy level can hold 2, the second energy level can hold up to 8, the third up to 8, and so on. And as those electrons move away from the nucleus and exist at those higher energy levels, they have higher amounts of energy. And it is specifically those outermost electrons, those valence electrons, that when we talk about bonding, that we're dealing with. And those are the ones that give the elements their different chemical properties. Okay, we talked briefly about how we can represent those valence electrons. We can use the electron dot diagrams or the Lewis structures to show how many valence electrons exist. We know we simply look at the group number of where the element is located on the periodic table, and that gives us information about how many valence electrons it has, and we simply put dots around the symbol to illustrate that. Specifically starting at the right, and we work our way around counterclockwise. Okay, so what is it that an atom wants to have? Why is that atom going to either transfer, so it's either losing or gaining, or maybe even sharing electrons? It is because they want to have 8 valence electrons. They want to have 8 electrons in their outermost energy level. And so atoms are going to do what they have to in order to get those 8. And when they do that, a chemical bond is formed. And it's just the attraction that's holding atoms together because those electrons have been rearranged. 3 types of bonds: ionic, molecular, and metallic. So let's talk about each one of those individually. Let's start with those ionic bonds. Okay, so in order to have an ionic bond, you got to have an ion. And what is happening with an ion is now an atom, which typically is neutral if we're just dealing with the periodic table, but now we have an atom that has lost or gained electrons. So now we have a different number of protons than electrons. And so because of that now, our ions or our atoms have these charges. And when atoms, sorry, let me take a step back. We know that certain atoms will lose electrons. We know that certain atoms will gain electrons in order to have that stability that it wants. And then these oppositely charged particles, if we're losing an electron and becoming positive, or if we're gaining electrons and becoming negative, we now have these oppositely charged particles that will attract each other, forming an ionic bond, which makes an ionic compound. Now, one thing to keep in mind, though, is that these atoms might start out with a charge, these ions rather, will have this charge, but when the compound is formed, the compound overall is neutral. It has no charge. Okay, so we've talked about and we've seen in web quests and in activities how the electrons can get transferred from one atom to another in order to create those ions. Now, in writing the formula for an ionic compound, we have to make sure that we include subscripts, which tell us the ratios of how many atoms of each element are there. In order to do that correctly, we write the symbol of the positive ion first. So the metal will always be written first, then the symbol for the negative ion or the nonmetal. We add the subscripts. Remember how we crisscross those charges? If there is no subscript, then we just know that it's one. It's understood. Now, when we're naming ionic compounds, we want to name the positive ion first and then the negative ion. And that negative ion, the ending gets changed, and we change it, we drop the ending, and we add IDE. Okay, now, we know that atoms don't have to lose or gain electrons in order to form a bond, but they can share them as well. And when two atoms share electrons, that is a covalent bond. And we're going to see that covalent bonds form between non-metal atoms. So that's a great distinction that you need to make sure that you check and you observe before you move on when we're dealing with naming or writing formulas. You need to look at what the compound contains. Is it a metal and a nonmetal, or is it two nonmetals? It's important that you do that. But anyway, getting back to molecular compounds or the covalent bonds, two nonmetals. Okay, so here, one isn't giving up, one isn't taking, we're simply sharing. And because they are sharing, they now have that valence shell with the 8 electrons that both the atoms want. And a molecular compound is a compound that is simply made up of molecules. And we can see here in the covalent bonding, they are simply sharing those electrons. Okay. All right. So now the cool thing with covalent bonds and the sharing of electrons is that atoms can actually share more than one pair. And so they can form single, double, or even triple bonds depending on how many pairs of electrons they actually share. Okay, now another thing that's really cool about covalent bonds is that we know sometimes we don't always share equally. And guess what? Atoms don't share equally either, not all the time anyway. And so one atom that will actually hold on and pull those electrons a little bit more than another atom. And so that actually creates a slight electrical charge in that new molecule. And so if there's a covalent bond where electrons are shared equally, I mean, we can see these two hydrogens here, they're sharing them nicely, then that's a nonpolar bond. Everything's equal. But let's say that there's an atom that's a little bit bigger and a little bit stronger than the other one that's making up that molecule. Then that atom can actually hold on to those electrons more tightly. Their electrons are not being shared equally, and it creates a slightly charged particle, where one end has a slightly positive charge, the other has a slightly negative charge, and that is called a polar bond. Okay, and then last but not least, we're going to spend just a brief moment on metallic bonds. We know that metals have all of these wonderful properties. They are shiny, they are ductile, they conduct heat, they conduct electricity. And the reason that they do that is because of the structure of the metal atoms and what happens when they lose their valence electrons, which we know the metals want to do. So when that happens, the metal cations, now we have these positive ions that are left, become pretty closely packed together. And we have these valence electrons that have been given up sort of drifting among all those positive ions. Well, each metal ion is held together by a metallic bond, or that attraction between the positive metal and all of those electrons around it. So that's just a little bit about the metallic bonds that helps us understand why they have those properties that they do. Okay, so again, 3 types of bonding: ionic, covalent, and metallic. Okay, till next time.